Hello, on this video I'm going to talk about C++ data type conversion, and I'm going to talk about implicit and explicit data conversion together with some typecasting. Alright, so let's take a look on the implicit way to convert data. I'm going to do something very simple here, and then I'm going to work on some calculations and mixing matching some data type. So let's start with a very simple implicit conversion. So let's say I have a variable here, int x, and I'm going to assign this 2.5. We know the 2.5 is not a integer. So when I run this code here, I'm going to let the compiler doing a implicit data type conversion. What that means, I'm going to let the compiler convert 2.5 into an integer. In this case here, it's going to be a 2. So if I display the value of x, I'm going to end up with a 2. Alright, but I'm still forcing this value to be an integer. And I'm losing data here. I'm losing the 0.5. But if I really want to let the compiler to choose all the conversion for me and also to choose the data type for me, I can put auto here. And when I put auto, I'm letting the compiler decide what type of data type the x will be. And also I'm letting the compiler decide what kind of conversion it's going to do from 2.5 to whatever data type is here. When I run this program, I get 2.5. So the compiler chose a data type appropriately for me that I did not lose any data. But now the question is, what kind of data type that the compiler chose for me here when he created the x variable? To display the data type, I'm just going to use a function, and it's the type ID function. And here I'm going to pass the variable and then .name. And this line here is going to display the data type of the variable that the compiler created for me. So I'm going to run this guy. And then here it says the data type they created for me is a double. So the compiler chose a double for me. Now, could this be something differently? Absolutely. You could do a float. And as a matter of fact, if I know that my data type is small, which in this case is, I, as a developer, would choose a float. Because float is smaller in size than a double. So if you choose double all the time, you're going to waste a bit of space in your computer. Now, I know that computers nowadays have plenty of space, but still, you're using a bigger container, a big data type, to store a small value. So that's a little bit of waste space. So I'm going to put the auto back again, and this is how I let the computer choose everything for me. Now I'm going to move on and do some mathematical calculation now. So let's assume this is a float 2.5, and then I'm going to have a int, and the int is going to be a 2. Then I'm going to have an int result, and I'm going to do some calculation between x and y. So the result is going to be x divided by y. And then here I'm going to display the result. I'm going to run it. And then I have 1. So this is another implicit way to convert data, doing a mathematical calculation here. So in this case, I'm dividing 2.5 by 2. And in real life, I should have 1.25, but I have 1 only. And I have 1 only because I'm forcing this result to fit into an integer. And when I force it to be an integer, then this 1.25 here gets converted to 1. So I'm losing data here. If I change this to, let's say, double, then I'm not losing any data. However, I did a conversion from float and integer to double. Now, every time you go from a smaller data type to a bigger data type, you usually don't lose any data. So the data type in C++ have a hierarchy and a size. And this hierarchy and size goes something like that. So Boolean will be your smallest data type, and then the little bit bigger one will be a char, and so on. And then you keep on going bigger, 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 all the way to long double. So long double is a very large data type. So generally speaking, when you go from a smaller data type to a bigger data type, you now start using more space in memory. You can store more values, and generally speaking, there is no loss of data. However, when you go from a larger data type to a smaller one, then usually, again, generally speaking, you might lose some data. Now, I'm pretty sure there's some exceptions on this rule, but again, generally speaking, when you go from a smaller data type to a bigger data type, you don't lose anything. Now, right here on the floating points here, it seems like C++ likes to choose double, even though it could choose float sometimes. So there's a preference for C++ to choose double. So let's do some more conversion here. I'm going to create a character now, a char C equals, I'm going to give it a value of capital A. And then I'm going to create a integer of x of value 2. So now I'm going to divide a character by a integer. So let's see what happens here. I'm going to display the value of the result, and I'm also going to display the data type of the result. So what happened here is when I divided the character A by 2, I got 32, and my end result was an integer. So this is because the ASCII table shows me that the letter A, the capital A, is 65, and then when I divided 65 by 2 in an integer conversion, I end up with 32. So I'm letting the compiler choose what kind of data type we're going to have. So remember, 32 is what gave us. The other way for us to convert data is to do it in an explicit manner. So instead of letting the compiler choose what kind of data type it wants, we can force these variables to be of a certain data type. So the C here is a char, and I'm going to force this to be a double. And to force this to be a double, I'm going to put a static cast, and then I'm going to cast this to a double. So this code here is forcing the letter C to be a double, and now I'm going to force the letter X to be a double as well. To do that, I'm going to do the same thing here. So, and I'm forcing here the variable X to be a double, and the same thing with the variable C to be a double. Now I have a double and a double division, and then the result here should be a double. So now I have a double variable, and the value is 32.5. If you remember, before it was 32, now it's 32.5. So the whole point of this video here is to let you know that when converting data type, you can do implicit, and implicit is when you let the compiler choose what kind of data type you're going to end up with. And then explicit is when you force the compiler, you force your values to be of whatever you want. So in this case here, on line 14, because I have a double and a double here, I do not need the auto and I can put a double. And if I run the program again, I get 32.5 and I get a double. Alright, so that's all for this video. Thanks for watching.